In this part of the lecture, what we want to do is try and bridge what we've learned about probability and the clustering techniques that we learned in the previous module. So in the other videos for this part of the lecture, we talked about discrete random variables, we talked about probabilistic independence, and conditional probability. Here what we want to do is talk about how probability applies to the clustering approaches that we've explored. And the way we'll do this bridge is looking at the movie clusters that we've been using as sort of the examples throughout the course, where we have code using k-means to identify clusters of movies based on the actors in them. So you can follow along. Essentially, the context for this is the k-means example that we've posted on GitHub in Module 4. So you can play with this to your heart's content if you want to use different values for k or apply different clustering algorithms for this. But ultimately, the way this works is going to use some of the numbers from this code. So what we do here, by fiat, we sort of specify that we're going to say k equals 32. We're going to say there's 32 clusters of movies here. Now, certainly there could be a different number, but for the examples that we'll do, we're going to focus on k equals 32. And the question is, if we know the number of clusters of being 32, what's the probability that a given movie is going to belong to a particular cluster? So if we know nothing about the clustering that we've created, or we haven't created this clustering yet, then what we have is called the prior probability. What is the probability of being in the X cluster? So if we get a new movie, we don't know what that movie is, but say we have some new movie, we want to understand what the probability is of that new movie being in one of these X clusters. And this probability of X is our random variable. And the way we would interpret this is, given some movie, what is the probability of this movie being in the X cluster? Now, because at the moment, or what we claim at the moment, is that we have no understanding or insight into what these different clusters are, then probably the best guess we can have about the probability of being in a particular cluster is just 1 over k. How many different clusters do we have? And we have a uniform probability across all of these clusters. So in this case, we set k equals 32. Then we have this is equivalently rolling a 32-sided die, and we get the probability of being in a particular cluster, the X cluster, as 1 in 32, or about 3% for each individual cluster. But after we run the clustering, and we can get some insight, maybe not even insight into what kind of movies are in these clusters, but after we run these clustering, maybe we have some insight about how big each cluster is, and then we can evaluate this differently. So here, this is after we've run this k-means algorithm against about 51,000 movies, and we see that the vast majority of these are actually in cluster 1. We've set this k equals 32 to these 51,000 movies, and we see 49,000 of them are in cluster 1, 178 are in cluster 8, 100 are in cluster 18. So now we can evaluate the probability of being in a particular cluster, PR of x equals 0. What's the probability of landing in cluster 0? PR of x equals 1. What's the probability of landing in cluster 1, etc. We can do that using the numbers that or the number of movies assigned to each one of these clusters. So for instance, the probability of being in cluster 0, there are only 36 movies in cluster 0 of the 51,000 movies that exist in our data set. So just by this naive approach, what's the probability of a new movie we haven't seen yet being in cluster 0? And the answer is about 0.0007, or about 0.07%. So it's pretty unlikely that a new movie is going to come in and be in cluster 0. Alternatively, looking at the probability of being in cluster 1, we have a much higher probability of this. So since the vast majority of our movies went into cluster 1, we see there are about 49,000 movies in cluster 1. That's about 97% of the data set. So if you see a new movie, just naively, we'd expect there's a very high probability that that movie would be clustered into cluster 1. But we know things about the movies that we're looking at. So rather than saying just some random movie, we don't know anything about which cluster is it going to go into based on the size of those clusters, we can ask it differently and say, well, what is if we know something about the movie, either the genre or actor, how does this change? If we don't know any of that information, we've already evaluated. So the most likely event is that movie is going to get cluster, or is going to be clustered in with cluster 1. But if we know the genre of the film, then we see a deviation in this. So say, for instance, we are interested in, or we see a new movie that's in the genre of sports, or a sporting movie. So here we can ask the question, what's the probability of being in a particular cluster, given that the genre of this movie that we're seeing is sports, or contains sports? And what we see is, looking at the different, all the different movies that have the genre sport, what's the probability of them ending up in different clusters? And again, we see that cluster 1 is the most probable cluster for a sports movie, but we've seen a pretty substantial drop in the probability, going from about 97% to about 91%. And now cluster 2 is much more likely than it was. We're talking about 6%. There's a 6% chance that a sporting event, or a sporting movie, is going to land in cluster 2. We could ask the same question about other genres, say westerns, and we get a similar kind of result, that cluster 1 is still the most likely, or rather the most probable, but now we see cluster 8 is the second most likely, at about 1%, and most of the other clusters are unlikely, or have very, very low, or less than 1% chance. And you could ask this question about actors as well. So you might ask, what's the probability of being in a particular cluster, given that Kevin Bacon is in this film, or given that John Wayne is in this film? And you could stack these as well. So you might ask, well, what's the probability of being in a particular cluster, given that this movie is both the genre Western and has the genre sport? And we'll talk about how we can build up those more sophisticated sorts of conditionals next time, when we talk about Bayes' probability, or the Bayes theorem in probability. So hopefully that gives you some insight about how we can use probability to understand the clustering that we've developed in the previous module. And you can see some of how that might help us get to the classification case in the supervised learning case that we'll talk about in the next module, where if we look at these clusters as being labels, where we actually knew something about what these clusters meant, or we've somehow attached meaning to these cluster items, then you might think of them as you might think of the cluster indices as actual labels that we're trying to recover, and we could see, based on this data, that the most likely label for any new movie is going to be cluster 1, or receive that label of cluster 1, but the genre can change what the other likelihoods are. And if you play around with this in some of the examples, and add additional genres, or add actors to this, and make the conditional more sophisticated or more complicated, then you can actually get to a point where the most likely cluster is not cluster 1, but some other cluster. And that's going to help us when we do classification, because now we can generate rules for which cluster a movie is likely to go in, based on the actors and genres that we know about. All right, if you have any questions about this, or you want to see some of the code for this, that code is in GitHub, but you're also welcome to drop a question in the discussion forum, or reach out to me via office hours.